Hello, this video is going to be on how to find the standard deviation by hand, and I'm going to appeal to the definition of the standard deviation. So, actually, I also do want to mention that first, standard deviation should only be used on the normal distribution of the bell curve. It has to be a symmetric unimodal distribution, and it is a measure of spread. So what is it actually measuring? Well, standard deviation tells us, on average, how far each value is from the mean. Now that's a very important definition. You really should commit it to memory. But what we're going to do is we're going to take this apart piece by piece and actually calculate the standard deviation by hand following this definition. Okay? Now, when you read this again, standard deviation tells us, on average, how far each value is from the mean. What do you think you'd have to find first? Just pause the video, think about it. What do you think that this definition is telling you that you have to find first? So hopefully you realize it's the mean. We have to find the mean. So what we're going to do is look at an example. And here in this example I'm looking at how long it takes me to get to work in minutes. I time myself, I take 6 measurements, and these are the minutes that I get. And I've put them on a number line so you can kind of see them. But if I have to find the mean, then the first step is to go ahead and find the average. So we're going to say X bar or Y bar. Normally most people use X bar. Our book in particular uses Y bar. But essentially you're going to say then is 25 plus 17 plus 23 plus 28 plus 15 plus 12 divided by how many values there are, 6 values, and you get 20. So my mean is 20. Now, let's take a look at that definition again. So we found the mean. All right. Now let's take a look at what it's asking us to do. It says, on average, how far each value is from the mean. So we then want to know distances, how far each value is from the mean. So if we look at then our number line, and we go ahead and put our mean on here, our mean came out to be, here, 20. So if I look then and I say, well, how far is, for example, this value, 28, from 20, what would you say? You'd probably say 8. And if I asked you, well, what did you do in your head? You'd say, well, I just took 28 minus 20. Well, that's exactly what we're going to do for every value. We're going to find out how far each value is from the mean. All right, so let's go ahead and do that. All right, so the way we're going to write that notationally is how far is each value, each y value, from the mean y bar. Okay, so let's take a look. If we say, oh, how far is 25 from 20? You'd say 5. How far is 17 from 20? You'd say, well, it's negative 3, right? It's to the left. How far is 23 from 20? Well, that's positive 3. How far is 28 from 20? 8. How far is 15 from 20? Negative 5. And how far is 12 from 20? Negative 8. Okay? Now let's go back to our definition. And we found our mean, and now we found out how far each value is from the mean. So we've done that. And now we're asked to find the average of how far each value is from the mean. Now normally an average, you add up the values, whatever values you're looking for, and divide by how many there are. Well, in this case then we want to add up our how fars and divide by how many there are. So let's take a look. Well, if we added these values up, these are our how fars right here, right? If we added them, and by the way, the Greek capital letter E is the symbol for sum. If we added them, we'd see we get 0. But I know that the spread is not 0, right? Because for the spread to be 0, I mean, I haven't even divided by, I would take 0 and divide it by 6, but we know that's going to be 0. The only way that could happen is if all the values were exactly on top of 15, the mean, I'm sorry, 20, the mean, and therefore how far is each value from the mean? It's no distance at all. That's the only thing that would make sense for 0, if all my data values were piled up on top of the mean, 20. But that's not happening, so I know this can't be so. So why is this happening? Well, if you recall in an activity, which measure of center is better, the median or the mean, you recall that the mean is the center by distance. So essentially all the distances to the left of the mean have to always equal the distances to the right of the mean. So will this always happen? Yes, this will always happen. So what do we do to get around this? Well, what we do to get around this is to compensate. For the canceling effect, we square the distances. Okay, so that's going to look like y minus y bar squared. All right, so let's do that. 5 squared, 25. Negative 3 squared, 9. 3 squared, 9. 8 squared, 64. Negative 5 squared, 25. And now negative 8 squared, 64. Notice now all these values are positive. They can't cancel each other out. So if you look at this now the sum is 196. All right? So let's go back to our definition. Standard deviation tells us, on average, how far each value is from the mean. We found the mean. We found each distance from the mean. We started to take an average, but found out that the sum would always be 0. So we squared the distances, or the how fars. So we're still trying to find an average. So let's take this 196, and let's see what else we're going to do now. Now, technically, a true average would be 196 divided by 6, which would be 32.67. But we want an overestimated, a slightly overestimated average. Why? Because we'd want to err on the side of caution. We would rather say that the spread is a little larger than it is, just to be safe. So to do this, to overestimate, we will divide by n minus 1, where n is the number of data values. Okay, so we're going to take 196 and divide it by 6 minus 1, which is 196 divided by 5. And here you're going to get 39.2. Okay, notice it's a little higher. Okay, now let's go back. Again, we were trying to find out on average how far each value is from the mean. We're almost there. We did find an average, but what we did is we squared the distances to get there. So one of the things I want to do now is to undo the squaring process. I bet you can guess it. What undoes a square? We take a square root. So the square root of 39.2 is 6.26. Okay. So now we're finally there. Let me just write a sentence to interpret this. The standard deviation denoted by the letter S is S equal 6.26. Okay. Now, if what you'll see sometimes in books is they'll say S is, and they'll say the square root of this sum of the y minus the y bar squared over n minus 1. Essentially, that's what we've done, right? What we did is, let me put this process over here. If you want to pause the video, you could write these down, or, you know, we found the mean, then we subtracted the mean from each value. That was to find out how far each value is from the mean. Then when we went to go take an average, we saw that things canceled out, so we squared the differences. Then we went ahead and continued with our average, so we added the squared differences, divided this by 1 less than the number of data values for a slightly overestimated average, and then we took a square root. Okay? Essentially, that's what this formula is doing. How far is each value from the mean? Then you square these distances, add up the squared distances, divide by 1 less value, and take a square root. Okay? Now, you can do this on your calculator. Let's go ahead and just see how easy this is. I'm going to go ahead and open up Stat, and then I'm already in Edit, and let's put in these values: 25, 17, 23, 28, 15, and 12. I have all my values in. I like to go second mode so that I quit onto a nice home screen and I make sure it's nice and clear. Then I go back and I say Stat. I want to access Calc, so I go to the right one. I'm already on one variable statistic, so I can either press 1 or Enter. And then I want to tell the calculator where that list is. Remember, all your lists are above your numeric buttons, so my information is in L1. I want to do second 1 to access L1. Press Enter, and there it is. Notice here S of x. So the standard deviation of those x values, the calculator uses x bar and x's. So x bar, the mean is 20. S, x sub x is 6.26. There's your standard deviation. And just notice that if you had that arrow there, it's begging you to kind of go down. You also have your 5-number summary. All right? Thank you for listening.